Good morning, everybody. In this chapter, we are discussing about plane motion of rigid body. There are many types of motions. There are translatory motion, angular motion, plane motion, etc. Here we are discussing the plane motion. Before entering to the plane motion, we have to understand what is translatory motion. You consider that in translatory motion, all points in the rigid body parallel to each other and their paths are straight lines. You consider this body AB. This is the body AB. This is the final position of the body is AB. Then the initial position of the body is AB. Initial position is AB. Then it is moved. B is moved to B1. A is moved to A1. That means the final position of the body is A1, B1. Initial position AB, final position A1, B1. In this case, each point is moved from here to here. This point from here to here. And the point A is moved to from A to A1. A1, this line and this line are parallel and both are straight line. Each and every points are moved from here to here in a straight line and all are parallel to each other. This type of motion is known as translatory motion. Okay. Next is rotary motion. Here also the initial position is AB. Initial position. Then it is moved to here through a curved path to here. Then the final position of the body is A1, B1. Okay. A1, B1 is the final position. Here also A moves in a curved path into B1. A moved into A1 through a curved path. Similarly, each and every point of body moves from here to here in a curved path. All these curved paths are parallel to each other. All are parallel, but not a straight line. It is a curved path. This type of motion is known as rotary motion. Clear? This is the rotary motion. Anyway, our area of interest is plane motion. We are discussing about the plane motion. Plane motion is a combination of translatory motion and rotary motion. We have discussed translatory motion and angular motion or rotary motion. Combination of these two is the plane motion. Clear? The best example is moving of a coin or moving of a round coin through a plane surface as shown in figure without slipping. Suppose this is the initial position of the coin. Then it rolls and reaches to this position without slipping. Here the body was in plane motion. Body was in plane motion. Okay. Actually, it is a combination of translatory motion and rotary motion. Okay. This point A is moved to here. That means from this was the initial position, then it reaches to here. Here. At the same time, this point A moved through a curved path and reaches to here from A to A1. Clear? The combination of these two motions happened and the body reaches to here. This type of motion is known as the plane motion. The best example is this one itself. As I told you earlier, the linear displacement of AA from this point to this point is achieved. Then angular displacement from A to A1, angular movement, both are equal. Okay, this displacement, linear displacement, and this displacement through this curved path, both are equal. Linear displacement is equal to angular displacement. Then this displacement can be from A1 can be calculated by using this formula r theta, where r is the radius of the circle. Theta is the angle turned in radians. Theta should be in radians. Then we get this displacement. Linear displacement equals angular displacement equals r theta. Okay, you kept in mind this angular displacement and the linear displacement are equal, and this displacement can be found out by using the formula r theta, where r is the radius of the circle, theta is the angle turned in radians. Our next topic is velocity. Velocity in plane motion. As I told you earlier, linear displacement is equal to angular displacement is equal to r theta. We know what is velocity. Velocity of the center. Okay, we have to find out the velocity of the center. How can we find out the velocity? Velocity is nothing but ds by dt. We have studied earlier. Velocity is equal to ds by dt. Then velocity of the center, so it is suffixed by c. Okay, velocity of center. Anyway, ds by dt is the velocity. Again, this can be written as d by dt of s. Yes, can be taken here. D by dt of s. But we know that s is nothing but r theta. S is nothing but r theta. That can be written here. Vc is equal to, or velocity is equal to d by dt of r theta, because s is equal to r theta. We know that r is a constant, that is the radius of the circle. That can be taken outside. Then r into d theta by dt. R is taken outside. D theta by dt. What is d theta by dt? D theta by dt is nothing but angular velocity. Okay, angular velocity. In other words, the velocity, linear velocity v is equal to r omega, where r is the radius of the circle, omega is the angular velocity in radians per second. We have to keep in mind linear velocity equals r omega, or r into angular velocity. Linear velocity is equal to r into angular velocity. For solving problems, this formula is inevitable. Clear? The next is acceleration. In the same way, we know what is acceleration. We have studied acceleration AC equals dv by dt. Rate of change of velocity is known as the acceleration. So, acceleration A is equal to dv by dt. We are discussing about the acceleration of center, so it is suffixed by c. Okay, that's all. Then we can rewrite it as acceleration A is equal to d by dt of vc. Okay, d by dt of vc, that's all. But we have studied what is vc is nothing but r omega. The previous slide we have discussed it. vc is equal to r omega. vc is nothing but r omega. So that can be written here. AC is equal to d by dt of r omega. Clear? Then we know that r is a constant, the radius, that can be taken out. R is taken out, the remaining d omega by dt. D omega by dt is nothing but alpha, that is angular acceleration. Angular velocity by the time is nothing but acceleration. So r into acceleration. That means linear acceleration is equal to r into angular acceleration. In the previous slide, it was linear velocity is equal to r into angular velocity. Similarly, the linear acceleration is equal to r into angular acceleration. Clear? The next is instantaneous center, not simply the center, instantaneous center. The plane motion means linear motion plus rotary motion, okay, of a body at a given instant can be assumed to be pure rotation of the body about a point. That point is called instantaneous center. That means, suppose this circular body is rolling on a surface like this, as we discussed. This is the center of the circle. O is the center of the circle. We can assume that now at this instant, for this instant shown in the figure, assume that the body is in pure rotation, not linear, only the rotation is there. If so, this point O is also in rotation about this point, this contacting point. Am I correct? This point is also in rotation. You consider this rolling motion and its translatory motion is omitted. You leave it. You consider only the rotary motion of each and every points of this body. Okay. Suppose O rotates about this point, this contacting point. Similarly, A is also rotating. A rotating about this point. Okay, at this particular instant. Then you consider another point here, somewhere here. That is also rotating. As shown by the arrow mark, it is rotating in this direction. This center of rotation is nothing but this point, this contacting point. That means each and every point of this body rotates about a particular point at this instant. That particular point is called instantaneous center. At this instant, this is the center. After this instant, the body rolls and another point comes in contact with this one. At that instant, that point will be the instantaneous center. Clear? Okay. That is the idea of instantaneous center. We know that the velocity of instantaneous center at that instant is 0. Am I correct? At this instant, all the points of this body are rotating about this point. What about this point? Is it moving? No, that's at that instant that point O is static. So its velocity is 0. Velocity at that instant, the velocity of instantaneous center at that instant is 0. Okay. But there is each and every time, every instant, the instantaneous center changes. At this instant, the point here, this point is here. This is the instantaneous center. When rolling, this point reaches to somewhere here. At that time, there will be another instantaneous center. Then this may reaches to somewhere here or somewhere here. At the same time, there will be another instant. The locus of these points, locus of these instantaneous centers, that path is known as a centroid, not centroid spelling. You should be careful about the spelling, not centroid. It is known as a centroid. You can expect at a question like this. What is the difference between centroid and centroid? Both are different. Centroid that we have studied in the third module. Okay, moment of inertia, etc. Okay, in that case, we have studied about the centroid. That is something different. Here, we are discussing about the centroid. Centroid means the locus of the instantaneous centers. Instantaneous center in the locus in the centroid. Yes. Then, methods to find out the instantaneous center. How can we find out the instantaneous center at each instant? ഓരോ ഇൻസ്റ്റന്റിലും ഇൻസ്റ്റന്റേനിയസ് സെന്റർ കണ്ടുപിടിക്കേണ്ടി വരികയാണെങ്കിൽ അതെങ്ങനെ കണ്ടുപിടിക്കുക എന്നുള്ളതാണ് our next idea. There are different cases. The first case is the direction of velocities of 2 points in a body are known. Our body is AB. AB ആണ് body ട്ടാ. AB. We know the velocity, direction of velocity of A at this instant. We know that is in this direction. This is the vector. We know velocity is a vector quantity that can be represented by this one. Point A, its velocity is VA, and that velocity is in this direction. ഈ ഡയറക്ഷനിലാണെന്ന് നമുക്കറിയാം. അത് വരച്ചിടുക, ആ വെക്ടർ വരച്ചിടുക, വെക്ടർ ആരോ മാർക്ക്. We know that the velocity of the point B is also known. Velocity of the point B is also known to us. That may be VB. VB is in this direction. Velocity of B. ഈ പോയിന്റിന്റെ വെലോസിറ്റി ഈ ഡയറക്ഷനിലാണെന്ന് നമുക്കറിയാം. ഈ പോയിന്റിന്റെ വെലോസിറ്റി ഈ ഡയറക്ഷനിലാണെന്ന് നമുക്കറിയാം. Both are marked like this as a vector. Okay, this is known as the vector head. Vector head. Okay, both are drawn. Our aim is to find out the instantaneous center at this instant. ഈ ഇൻസ്റ്റന്റിലെ ഇൻസ്റ്റന്റേനിയസ് സെന്റർ കാണാന്നുള്ളതാണല്ലോ നമ്മുടെ എയിം. For that purpose, we have to do something. VA. This is the one velocity. You draw a perpendicular to this VA. ഈ VA എന്ന ഈ വെക്ടറിന് പെർപെൻഡിക്കുലർ ആയിട്ട് ഒരു ലൈൻ ഇങ്ങനെ വരച്ചിടാം, നീട്ടി വരച്ചിടാം. ഓക്കെ, you draw a line perpendicular to this first velocity. Similarly, you draw a perpendicular to the second velocity VB. അതിനും ഒരു perpendicular വരയ്ക്കാം. Both will meet at a point. That will cross or meet at a point. That point is nothing but instantaneous center. ഇതായിരിക്കും എൻ്റെ ഇൻസ്റ്റന്റേനിയസ് സെന്റർ. എന്തൊക്കെയാ പറഞ്ഞത്? ഇതെല്ലാം അവിടെ എഴുതിയിട്ടുണ്ട്. Let velocity at A is VA. Velocity VA എന്ന് നമുക്ക് വിചാരിക്കാം. Velocity at B is equal to VB. ഓക്കെ, പറഞ്ഞ കാര്യങ്ങളാണ്. Draw perpendiculars. You draw a perpendicular to VA. അതാണ്. You draw a perpendicular to VB. അത് ഇതാണ്. The meeting point, the intersection of these perpendiculars is I. I is the instantaneous center. And one method. It is applicable only when the directions of these two are known and both are not parallel. Then the parallel VA, VB are not parallel. In this case, we can find out the instantaneous center following this method. Second case, direction of velocities are known. Our body is AB. Its velocities are known. Velocity of A is known and it is in this direction. And the velocity of B, that is also known. That is in this direction. Both are opposites. Both are parallel. Both velocities are parallel, but directions are opposite. Okay. അപ്പോൾ നമ്മൾ എന്ത് ചെയ്യും? First of all, you draw the object AB. AB is drawn. Then the point at point B, velocity VB. It is drawn to here. Velocity is drawn. VB is drawn. And an arrow mark. That is the velocity. Vector head is drawn. Again, velocity at A is also known. It is parallel to this one. Okay, drawn. Then you connect the arrowheads. Arrowheads means vector heads are joined by means of a straight line. You will get a meeting point here. Okay, that meeting point is nothing but instantaneous center in this case. രണ്ടും പാരലൽ ആണ്, വെലോസിറ്റീസ് ഓപ്പോസിറ്റ് ആണെങ്കിലാണ് ഈ മെത്തേഡ് അല്ലേ. ഇനി ഇതുപോലെയാണെങ്കിലോ, ബോത്ത് വെലോസിറ്റീസ് ആർ നോൺ. A is in this direction. Velocity VB is also in this direction. Both are parallel. അപ്പൊ എന്താ ചെയ്യണ്ടേ? നമ്മൾ എ ബി നേരത്തെ വരച്ചിട്ടുണ്ടായിരിക്കും അല്ലേ, അതിങ്ങനെ എക്സ്റ്റെൻഡ് ചെയ്യുക താഴെ. യു എക്സ്റ്റെൻഡ് ദ ലൈൻ എ ബി. യു ഓൾസോ കണക്ട് these two arrowheads. Arrowheads means vector heads. Both are joined by means of a straight line and extend it. There will be a meeting point. That meeting point is the instantaneous center. Okay. These are the methods for finding the instantaneous centers. Before entering to the problems, we have to keep in mind some formulas. Some relations should be kept in mind before entering to the problem. First one is this one: displacement is equal to r theta. Linear displacement or angular displacement both are equal. That is equal to r theta, where r is the radius, theta is the theta is the radius. R is the radius and theta is the angle turned. That should be in radians per. So that should be in radians. Okay, r theta. Then another relation is velocity v is equal to r omega. Velocity, linear velocity equals r into angular velocity. Another relation, linear acceleration a is equal to r into alpha. Alpha is the angular acceleration. In other words, linear acceleration is equal to r into angular acceleration. Then methods to find out the instantaneous center. In this case, in simple case, this point, this contacting point itself is the instantaneous center. Okay, this is the instantaneous center. In this case, AB, any 2 points and its velocities are known. They are not parallel. Anyway, you draw that velocity vectors using arrowhead. Then draw the perpendicular to the first velocity. Draw a perpendicular. Then you draw the perpendicular to the second velocity, VB. VB ki perpendicular. The meeting point will give you the instantaneous center. In other cases, both are parallel. If they are parallel and in the opposite, it is very simple that arrowheads are connected. Then here there will be a meeting point. That meeting point is nothing but instantaneous center. In this case, both are parallel. Velocity at A, velocity at B, both are parallel, but both are in the same direction. Anyway, AB is extended and you draw a line connecting the arrowheads and extend it. The meeting point indicates the instantaneous center. This is the method for finding the. If you know this much, we can enter into problems. First of all, we are considering a simple problem. Okay. A cylinder of radius 1 meter rolls without slipping along a horizontal plane AB. Its center has a uniform velocity of 20 meters per second. Its center C has a uniform velocity of 20 meters per second. Find the velocity of the point D. Velocity of the point D and E on the circumference of the cylinders as shown in figure. The problem analyzing is very simple. What is it? Here there's a plane in which a cylinder has been rolling. A cylinder rolls on the surface. Velocity of the center is given. Linear velocity Vc is given. 20 meter per second. It is given. Then radius means OC or CE, whatever it may be. OC is 1 meter. Here, radius is 1 meter. Then we have to find out the velocity of D, point D, and velocity of point E. Okay, this is the problem. Before entering into the problem, we can identify the instantaneous center. Where is the instantaneous center? Looking to this problem, looking to this figure, Where is the instantaneous center? We can indicate very easily. O is the instantaneous center. This is the instantaneous center because at this instant, O rolls or rotates about O. C, this point C rotates about O. Am I correct? This point means C. The point C is also in simple rotation. If it is rotating, if the point C is rotating, which rotates about O, is it? Am I correct? Then, if the point E rotates at this point, ഈ പോയിന്റിൽ പോയിന്റ് ഇ റൊട്ടേറ്റ് ചെയ്യണമെന്നുണ്ടെങ്കിൽ this also rotates about O, keeping this as the radius, OE as the radius. OE radius ആക്കിക്കൊണ്ട് അവങ്ങനെ റൊട്ടേറ്റ് ചെയ്യും ഈ പോയിന്റിൽ, ഈ ഇൻസ്റ്റന്റിൽ. Clear? Then, what about D? This is also rotating. ഇങ്ങനെ റൊട്ടേറ്റ് ചെയ്യില്ല, എങ്ങനെയായിരിക്കും എറോ മാർക്ക് പോകുന്ന നോക്കാം, ഇങ്ങോട്ടായിരിക്കും റൊട്ടേറ്റ് ചെയ്യുന്നത്. Clear? At this instant. Here also, the center of rotation is O. D rotates about O. All the points rotates about O. So O is the instantaneous center. Clear? That's it. That is the striking point. Here O is the instantaneous center. Velocity of the center is given in the problem as 20 meter per second. We have studied that linear velocity v is equal to r omega, r into angular velocity. We have this relation. Okay, we have this relation. We are considering the point C. Point C ആണ് ഇപ്പോൾ കൺസിഡർ ചെയ്യുന്നത്. O ആണ് ഇൻസ്റ്റന്റേനിയസ് സെന്റർ എന്നൊക്കെ നമുക്കറിയാം. പോയിന്റ് സിയിലെ വെലോസിറ്റി തന്നിരിക്കുന്നു 20 മീറ്റർ പെർ സെക്കൻഡ്. ആ 20 മീറ്റർ പെർ സെക്കൻഡ് വി സി എന്ന് പറയുന്നത് എന്താണ്? ഇറ്റ് ഈസ് നത്തിങ് ബട്ട് ആർ ഒമേഗ. R is the radius, omega is the angular velocity. Okay. ഇവിടത്തെ റേഡിയസ് എന്ന് പറഞ്ഞാൽ O അല്ലേ, സോറി സിയുടെ വെലോസിറ്റി അല്ലേ 20. ആർ ഒമേഗ എന്ന് പറയുമ്പോൾ ഈ ആർ അല്ലേ, ആർ ഈസ് നത്തിങ് ബട്ട് 1 മീറ്റർ. Am I correct? It is 1 meter. VC is 20. It is given in the problem. OC or radius R is 1. Omega എത്ര വരും? Omega can be calculated. 1 into omega is equal to 20. Okay, then omega will be 20 radians per second. 20 radians per second ആയിരിക്കും അതിന്റെ omega. Okay, omega, that is angular velocity. It is constant for all the points. All the points in this figure, in this cylinder, is angular velocity is 20 radians per second. It is obtained from this relation. V is equal to r omega. Now omega is known. Then our aim is to find out the velocity of E and the velocity of D. Okay, our aim is this one. First, velocity of point E. We have to find out the velocity of point E. We know that velocity of E or velocity is equal to r omega. Formula is same. But what is r? We are considering this point. This point rotates. This point rotates about O. Am I correct? Correct ആണെന്നുണ്ടെങ്കിൽ at the instantaneous center O ആണ്. ആ instantaneous center about ആയിട്ട് ഇത് കറങ്ങും. Its radius is OE. OE will be the radius. Here, at this instant, E rotates about O, so OE is the radius. R should be OE. R should be OE. OE into omega. Then velocity VE, velocity of point E, അതാണ് കാണാൻ പറഞ്ഞിരിക്കുന്നത്, equals R into R എത്ര വരും? OE. ഇവിടെ വരെ 1, ഇവിടെ വരെ 1 അല്ലേ, ഈ രണ്ടും കൂടെ 1 + 1 = 2. 2 into 20 equals 40 meters per second. Then velocity at E is equal to 40 meters per second. That's the first answer. Clear? Our second question is, second point is D, its velocity has to be find out. Velocity Vd, velocity at D has to be find out. At this instant, D rotates about instantaneous center O. Okay. So what will be the radius of rotation? Radius of that rotation. നോക്ക് OD ഇതായിരിക്കില്ലേ അതിന്റെ radius of rotation. At this point, OD will be the radius of rotation. OD will be the radius of rotation. OD, how can find out? You consider this line, and this line. Now it become a right-angled triangle. It become a right-angled triangle. Okay. Then this one is 1 meter. This DC is 1 meter. OC is 1 meter. DC is 1 meter. Then this can be find out by using the Pythagoras theorem. Root of 1 square plus 1 square will be the OD. That is root 2. 1 is to 1 is to root 2. 1 is to 1 is to root 2. Root 2 will be OD. Okay. Root of 1 square plus 1 square. Then velocity of D is equal to R omega. R is root 2. R into omega 20. 2 into root 2. Root 2 into 20 equals 28.2842 meters per second. This is the answer. Okay, we have to do some more problems using these relations from this chapter. That will be done in the next video.